Hello everyone, this is Bradley. So I was kind of reviewing the tutorials I've made in the past, and I realized it might be interesting to make this kind of flipping book animation within geometry nodes. So let's just start. In this video, I'm going to use the presets I built for myself, so you can download them for free from the link in description. But you also don't need to really worry about that for the moment, because we're going to do some tedious work. I want to create this kind of half of the grid, so basically grid with offset, and I want to keep that as procedural as possible. So I'm going to use a little bit math formula. It's kind of very dumb math formula. There are also many different ways to do that. There is no real right or wrong, and I haven't tried all the methods, so I don't really know which one is the best. So now we have offset this entire plane. It only elongates from the center. Next, I need to really rotate this on Y so that it straights up. Actually, this is equally true when you're working with simple deform modifier, that you have to erect your object so that you have a correct rotation later. So what's very important here is I want to change these vertices so that I have subdivision, and all these kind of values is controlling the dimension, because I do not know the size of your book. Maybe it's a square shaped book, but more frequently I think it's something like this. Okay, so this is the page. Next thing, we're going to simulate a simple deform modifier. I think the vector. I'm not sure if developer will really make you a simple deform modifier in the future, but generally speaking, this vector rotate node is simple deform modifier. So here, let's take the ruler, and by rotating on Y, we have this kind of rotation, but it does not really look like a simple deform modifier because there is no differentiation. Okay, so we need to have a kind of fold to say, okay, the first point is being affected less, and the last point is being affected the most. That's why we need a directional fold. So here comes our preset, and we can use a combined ruler rotations. Let's connect this fold to the Y, rotation to rotation. So immediately there is nothing happens. So it's very important that you take this scale up. Also remember to take this XYZ to 2. So now if I change this maximum, then we can see its effect. We can also change the scale so that we basically this scale offset should be related to the dimension that we're using. So if it's 0.6, then I think I should take 0.6 as well. Doesn't really look like so. So let's take 1.2. So it seems like I need to take 2 times of that. I think it's related to how this node is working, but without a way to visualize that, it's kind of difficult. But I think this is the rule. Here, I think it's very important to actually understand how this kind of value is affecting all these kind of pages. Next thing is I need to have another controls on this X and Y so that I know where's rotation. And both of these maximum value and these add values are important for us to control. So one is for the general rotation, the other is for this kind of differentiation, or the simple deform modifier that we're going to control. This is kind of very important. So let's just another important thing, we're using degree. This is also kind of important. Once we have finished this kind of idea, let's start with instancing our pages. So let's take a point instance. Because we're instancing on the same place, just for simplicity of this tutorial, I'm going to take a mesh line. If you're not instancing in the same place, then you need to take. So here I'm not going to take the one that has already been set position. I'm rather taking this instance and eliminate the offset. So everything is being instanced at the same place. There is a reason to do that because we're going to differentiate all this kind of rotation for each pages. Next, I need to change. I need to realize the instance. This is a very important step. Often people forget because if you do not realize the instance, these are empties, and the empties does not contain vertices. You cannot vector rotate these vertices unless you realize them. Okay, and this count determines how many pages you do have. So once we have this, then we start to do these same rotations. And if we play these values, we only see one pages because everything is overlapping. So we need to find a method to actually distinguish one page from the other. The reason we have this kind of issue is because we realize instance, which actually combine all these kind of instances into a single mesh that contains 550 vertices. So we need to ask a certain group of vertices to treat themselves as a group. So they should be united, and the other group should be united as another group. So we have different group of vertices, which means different group or different pages. Okay. So to do that, this is a concept which I call as index converge. Okay. So for example, let's take a transfer attribute and let's transfer the index. I'm looping the original geometry, so you know this geometry is actually our pages, a single unit of pages, as you can actually see. So this is the single pages. So let's loop at this page instance, take this index per instance, and you can transfer various kind of attribute. For example, the index. So it might sound a bit dumb, but it definitely makes sense. And this attribute is transferred from our page geometry. So now we have this index attribute, and let's just plug that into this place. So now we have different pages being rotated as a different degree. So we can look that clearly by using a mask, and let's set a multiply. So now we have 5 pages being rotated with this degree. So the important part is that the pages really distinguish themselves. If you do not do this step, rather just using a single index, then you can see this crappy result. Actually, this is completely too chaotic. So they do not really consider them as a full page. That's why you have this differentiation from vertices to vertices. This is not really desired in this ad, but rather should be desired in this maximum control. That's why we need this step to really do that. But on the other hand, actually, this is just an example. In fact, we're not really going to transfer the index, but rather a concept called delay fall, because we're using this delay fall to really control the different timing for each page to rotate. So here, instead of transfer an integer, let's transfer a float. And let's plug this delay fall into this attribute. So whatever we're transferring here now is the delay fall result, which ranges from 0 to 1. There are several parameters that we need to talk about. So first, let's plug this attribute to the value. Okay. One parameter is the time, which is talking about the action. So here, let's take a mixed float, because this fourth value is outputting 0 to 1, which is factor 0 to 1. So here what we control is, I think we start from negative 90 degree and finally ends at 90 degree. And by playing these values, we have these kind of flipping pages. And in the meantime, you can actually see a little bit of separation. So there are several things you need to know. One is this step interval is control the interval from page to pages. Another is duration, like how many frames it takes for this 0 to reach 1. And the time is finally the trigger. There is also a variances in case you find, hey, there is no variances, everything is so averaged, following 100% ordered rule of this step interval, and you find it's a little bit boring. You want to add a little bit of variances, and this is how it comes. By default, it's 0.5, which I think is good enough. You can also change the seed. Okay, once we, it's also is. Maybe you are looking for that, maybe you aren't. I think I'm not looking for that because we're going to remap that for this directional fold. Okay. But this is the basic concepts for this basic animation. But definitely we need to control this directional fold so that we have a little bit interesting parts that should be going on. The magnitude of this the directional fold is very tricky to play around because it's not like our initial mixed float that we only defined a starting rotation and the end rotation. Because if you think about the animation, I want all these kind of pages to be flat at the beginning but also at the end. But it should be curved during the middle. So we still need to use this mixed float, but we need to do additional process, which is basically remapping this value from 0 to 1 to be something else, like a 0 to 1 to 0. Okay. So let's take a float curve. So we remap everything. So we want 0 on both ends. And let's just, for the moment, let's elevate this middle point. And I'm going to change these values for 0 to something. So this is the 0 part, and this is the 0 part. And let's plug these values to the maximum. And we can see this animation by playing at the time. We have a flat result, and it's curved. And finally, when they reach the destination, it becomes flat again. So this is good, but I also want this animation becomes more natural because this definitely looks something else. And I also wish when this page flips, it can change the direction in the middle. Okay, so to do that, I'm going to firstly disable this clipping and use this zoom out. Let's extend horizontal and change these two values. I also want to use the vector handle instead of the original auto clamped handle. Vector handle is a little bit sharp, so it depends on your preference or your choice. What do you want to use? So currently this is how this animation looks. It definitely looks kind of weird. So we can really try to improve these in detail. For example, just dealing with the values. Yeah, dealing with values is kind of very effective. Okay, I think this is good enough. Let's increase the step. Let's also increase the amount of pages. So instead of 5 pages, I'm going to have maybe 65 pages, something like that. And then playing these times. So now we have this nice page animation. One thing I want to mention is that I have this loop. So in other tutorials, you may see that this loop function is a Boolean box, just like this index and random. I've changed that to integer for some reason, but it has still been used as a Boolean at some point. Okay, so if there's a 0 loop factor, which means there's no looping. So if the animation finishes, it really finishes. There's no continuance. But if you take a loop factor 1, which means right after a page is finishing its animation, then it will loop. That's why you basically never have a flat pages at the moment, because once it reaches flats, it will loop. But this is definitely not desired. That's why you take this loop factor to 2 so that it will wait a while before it actually starts to loop. Okay, so these are parts that you have to decide by yourself when to start to loop, or and so on and so forth. Okay, the duration of this animation, and so on. So you can play around. There are lots of things that you can play around. There's no definitive answers. Okay, so this is kind of idea. So here we basically have finished this entire tutorial because we have basically this full animation being done already. There are several things I would like to mention, however, before I close up. Instead of keyframe this time info, people will add an expression of all these kind of frame or other things. But sometimes I do not really remember this expression. I do not know if I should add a X or not. Okay. So just to save my little bit brain cell, I made this node, time info node, so that it contains the expression by itself. So you just type whatever factors and frame. Finally, you play this animation. You do not need to even keyframe anything. So you do not worry, oh, I do not find my keyframes in the timeline, or I did not know the expression that I need to type in. You just have that. You just use this node. You finish everything. Okay. So this is kind of automated. Another important thing is frequently people ask, hey, what if I do not want my pages to be instance just a single point? It will be normally recommended you instance on a curve in this case. For example, a curved circle or a Bezier curve or custom curve, so that you have some thickness of your book pages. Okay. But once you're using curve or other things, you need to use a normal and align ruler to vector so that your pages is aligned properly at some level. These are beyond the scope of this tutorial, so I would recommend you to watch relative tutorial, because I've talked about the similar concepts in other tutorials, especially about this align ruler to vector. So I would not explicitly explain it in this tutorial. Okay, so the third point I would like to mention, actually this is probably the last point before I actually close up, is once upon a time people asked, what if I would like to stop at a specific page? What should I do? Okay, so this is a very interesting question, so I'm going to answer that. The answer is very, very simple. So let's take a float compare. Because we're counting the pages numbers, so we need to use the index to know if this is the first page or second page, and so on and so forth. Okay. We also need to know that the index always comes from 0. So, which means if our page number is 4, then its index is 5. In this case, if I want to stop it at page 4, then our greater than index should be 3. And we take a math node and to subtract this time, so that this is the concept of delay, this time input. And this value only output 0 to 1, no yet to yes. So we need to multiply with a magnitude so that it delays more than it should. So for example, in this case, I think I stop at page 4, and let's take that 1 billion or whatever stuff, so that we play this animation, we flip the 4 pages, and it stops. If we do not have this loop, then this animation will just stay there forever. If we want it to flip again, then we type a legitimate numbers, maybe 100 frames, 200 frames, and basically we play this animation. After 100 frames, it will start to flip again. Okay, we can make this into a group node. So we have this node, and Control G, put them into a group nodes. You can name whatever you want. Stop at page. We also need to expose these values for the comparison. And if you want to repeat the process, then you just keep these entire things. Like I want to stop at page 3, I also would like to stop at page 45 or 35. You also probably want to expose this value so that you know how much time you actually really stop. Maybe you want to type 1 billion so that it just stops there forever. But these are just the kind of thing you can do. Finally, I would like to talk about the materials. There's no real ways to put different materials on the objects that you created in this case. It will come in 3.1, but not 3.0. So the most efficient way in this particular case is that you import image texture and then use this object that already contains all this kind of image texture. Okay, so we use a single geometry as an instance. We separate the children's, then it should be fine. Everything is in order. You can also reset the children. Does not really matter. It actually probably matters, but you can just tick all this kind of box and then finally pick instance. But for this kind of this part transfer, then you should pick one of the pages. For example, I have a plane, so I have another plane that as a part of the imports that I have, this import image texture. So you take the object info, you take this plane, and you take this plane geometry. So that should be fine if you need all this kind of texture. So this is the idea. So I hope this tutorial is not too overwhelming. So I hope you enjoyed this tutorial. I'll probably see you next time. If you have any questions, you can ask me in Discord server. That all these kind of links are posted in the description. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.